In this video, we're going to continue our work with critical path analysis and look at scheduling. Unlike some topics in decision maths, scheduling doesn't have an algorithm as such. We are given some guidelines, but it's basically a case of using common sense to find a possible solution. Let's start off looking at some of the assumptions that are made. We assume one worker does one task. Once that worker has started the task, they will complete the task. Once they've completed the task, they're ready to start a new task. So let's recap those again. One worker does one task. Once the worker has started the task, they will complete the task. Once they've completed the task, they're ready to start a new one. We are given some guidelines. Essentially, we use the first available worker. So if we have an activity or task that needs completing, we pick our first free worker. If we've got a choice of activities, we choose the one with the lowest late event time. So let's look at that in action with a basic question. In part A, it says draw a Gantt chart to represent the project. In part B, it says schedule the project to be completed by the minimum number of workers in the critical time. We're asked to state the number of workers required. So here is our activity network. So this might be a project to build a house. We're given time periods. These might be days, weeks, months, might even be seconds, minutes or hours. We can see now that the critical time is 31 time periods. So we need to ensure if this is completed on time, we get all of these in order and we end up now with 31 time periods. Okay, the first thing I want to focus on now is stating the number of workers required. This is what we call the lower bound. The lower bound is the absolute minimum number of workers that can complete this in the critical time. We calculate that by adding up the weights on these arcs. So we add up the total time taken to do all of the activities and divide it by the critical time. And that gives us our lower bound of workers. Now, the lower bound doesn't tell us how many it's going to take. It just tells us the absolute minimum that it would take. So, for example, if we had a lower bound and it rounded up to 3 workers, and we had 4 activities starting at the same time, then we couldn't do it with 3 workers. So let's go ahead and calculate that lower bound. So what we're going to have then is the following. We're simply adding up these values. So we're going to have 8 plus 6 plus 7 plus 9, and then let's move this across, plus now the 5 plus the 4. So let's add these. And then we're going to have another 5, so plus 5. Then we will have now 5 and 8, so plus 5 plus 8. I'm just scrolling across so I don't miss any, plus 5 plus 5. So our total now activity time is 67 time periods. So what we've got then is 67 divided by 31. That's going to be now equal, let's do that, let's divide this by 31. That's going to be now 67 over 31, 2.161 and so on and so forth. So 2.161 dot 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 dot. Therefore, our lower bound, the absolute minimum number of workers that we can do this in to ensure that we finish on time is going to be now, and we'll write therefore lower bound is 3 workers. Now, in this particular case, it looks quite favourable for us. That doesn't mean that we can definitely do it with 3 workers. That's just the lower bound. Okay, let's go ahead and draw a Gantt chart or a cascade chart. If you haven't seen the video on that, please do watch that, as I'm going to assume a basic understanding. I'm first going to find the critical path or paths in this activity network. So we can see 0, 0, 8 and 8, and activity A is 8, therefore it's critical. It's got a float of 0. These 2 times are the same, these are, and now it matches up. So next one, 8, 8, 17, 17, 9, that is critical. 17, 17, 21, 21, 4, critical. 21, 21, 26, 26, 5, so that will be critical. 26, 26, 31, 31 and 5. Let's just check there are no other critical paths, and as we can see, the early event times and late event times are all different. So we can see that our critical path is A, C, F, I, J. If you are new to that, please check out the video on drawing a Gantt or cascade chart. Okay, so what we're going to do is show that on here. So taking my critical path, I can start that now at time 0. Because this is a critical path, these have a float of 0. They must start and end on time, such that this whole project is not delayed. So let's go along and just put these on. So we've got 8, and we'll put that just there. That's going to be A. Then we've got 17. 17 looks to be just there. Then we've got now 21. 21 is going to be there. And then the next one is going to be 26, which is just there. And then finally we've got the 31. So let's go ahead and just label these up. So this is going to be A, this is going to be C, this will be F, I and J. So that is my critical path. What I'm now going to do is look at adding the others in alphabetical order. So let's first consider B. B can start at time 0, it takes now 6 time periods and can finish as late now as 13 time periods. That means B has a float of 7. So let's put this on, start at 0, finish at the earliest at 6, and then we can now show the float. We show the float by a broken or dotted line, and I can take that out now to 13. So 13 is going to be just here, and then we'll put that on. So that now is my first activity outside the critical path, and that is going to be B. So let's go ahead and just write on here B. So this now is the Gantt or cascade chart. Okay, alphabetically, next one is going to be D, as we got C in the critical path. So we're going to put that on. We can start that now at time 8. It's going to take 7, and we can go up to 21. So here now is the 8, so let's put that on. We've got now time period of 7, which will take me to the 15, and then we've got now 21. So if you want those key pieces of information, you've got now 8, 15, 21. So let's do that, and we'll go out to 21. Your accuracy should be slightly better than mine. Doing it on the computer is never ideal. So let's go ahead and put D on. D is going to be just here, and you can see we've now put our float on. Okay, let's now look alphabetically. The next one is going to be E. So we've got 6, 11 and 18. So let's go ahead and do that. So let's locate 6. So we've got 6 just here. We've got 11, which is going to be there. And then we can take this out now to 18. So just a bit of a recap in terms of our activity network. This tells me that E cannot start until B has been completed. And we call that a dependency, or if you like, it will come from a precedence table. So let's take this out now, and that looks to be 18, and we'll drop this down and then go across. So I've now put on my float, and I can label this up, and that is going to be E. So E is done. Alphabetically, the next one is going to be G, as F forms part of our critical path. 15, we got 5, we've got now 26 and 26. So on this one, I can go from 15 to 20 and take it out now to 26. So let's do that. 15, so we can start now at 15. We can take this out to 20. Let's check that, and that looks to be right. So we've got 15, 20, and then we've got now 26. So let's do that. Let's grab this up, and then we will go out now to 26. So that is going to be just there. So 26 is just there, and that gives us the float. And we can see now that the float in here is going to be the 6 time periods. So let's go for that, and that one is going to be G. So G, of course, is not part of our critical path. Okay, that leaves us now with H and K. We've got 11, we've got 8, and we've got 26. So 11, 8, let's put that on. So we can start this now as early as 11. So that, let's find 11. There's 10, and let's get 11. 11 is going to be just there. And then now we've got on this one, let's do up to now 19. Let's do that. So we've got 11, and then that'll take me to 19, which is going to be just there. And then we can now have this finish as late as 26 time periods. Ideally, I would have this now all on the same page so I could see what I'm doing, but ultimately it's fairly logical once you have got into it. So let's go and label that up. We can label this one H, and that now leaves me K. So K is the final activity that we need to put on the Gantt or cascade chart. We've got 11, we've got 5, and we've got 31. So this has got an absolutely massive float. So let's go ahead 11, so let's take this from 11. 11 is going to be just here. We can take this out now to 16. 16 is going to be just there. And then we can finish this as late as 31 time periods. So this does not need to be completed until now the end of the project. This can go to the end. So that's what we're going to have. And it will look something like so. So on here we can put that this is going to be K. So we've now done the Gantt or cascade chart. We now need to go on and do part B. It says schedule the project to be completed by the minimum number of workers in the critical time. State the number of workers required. So if this was an exam question, you would do your lower bound and you would now round up. Quite clearly it's going to take more than 2 and we simply round up. Now with this, with the 2.1, this is suggesting that this should be fairly easy to do. So in the exam questions, they're not going to give you anything that's going to take 40 minutes and a lot of playing with. Most exam questions will give you a fair bit of scope. We were given the guidelines, but we don't have to ultimately play by them. We just have to have some appreciation of them. So let's just recap those. We use the first available worker. If we have a choice of activities, we take the one that has the earliest late event time. So let's go ahead and do this. The first thing that we do in general is assign the critical path to worker number 1. So I can kill all of these right here with one worker. So this is going to be my scheduling chart. So I'm going to put here, this is worker 1, and I'm going to assign the critical path to that worker. He or she can take each and every one of these, not have a break, and end up now going from start to end, doing these back to back. So when we looked at the assumptions, we said once a worker has completed a task, they are ready to start a next. We assume that they are like the Energizer Bunny and they have no travelling to do between them. So as soon as they down tools on one, they start on the next. So let's go ahead now and just show this for worker number 1. So we've got now 8. So 8 is going to be there. Let's just change it over. Let's get that's the one we want. We want this one. So let's go and do that and put this on. So we want 8, which is going to be just here. Then the next one we've got was for 17, 21 and 26. So 17, 21 and 26. So again, ideally you have this in front of you and you can go ahead and just put these on. So we've got now the critical path A, C, F, I, J. So A, C, F, I and J. So that is one worker. We've allocated all of those tasks. Now at this stage I need to introduce worker number 2. We can see that worker number 2 can take B and B can start from time 0. So what I'm going to do is have worker number 2 here and I'm going to allocate worker number 2 the task B or activity B. So let's go ahead and do that. So B, we can start at the beginning. We can see from either here or here that this has now a time period of 6 units. So if this is completed on time 6, we will go to here. Okay, now what I'm going to do on my Gantt chart is just tick the ones I've done. In the exam you wouldn't do this, but it just gives me a record of all of the activities that I've assigned to the different workers. We can see after 6 time periods that B can be complete. That means worker 1 has now finished. If we look down the line, I can then give him or her activity E to do. So he won't be or she won't be standing around. They can start activity E straight away. So let's go ahead and now allocate activity E to worker number 2. So on here I'm just going to put B. Before I forget, put B, and now let's do E. So if we look now at E, E is going to take 5. So what we've got is the following. We've got now 5. So 5 looks something like that. And again, this isn't hugely accurate, but gives you some idea. So E is there. Now, when we're doing this, it's important to check now that we are meeting the dependencies of now the activity network. If we look at E, I've started it after B. So with B, E has to now only start, or B has to finish before E starts. So I'm not breaking any now of the dependencies here. And it's important that you go over at the end and check that you haven't done that. Remember, these now all have to adhere to the precedence table that you completed this from, or if you like, the dependencies. Okay, so that's where we stand. Now we're at this time here. So that is now where worker number 2 is. That means that I can introduce now worker number 3 and start worker number 3 on task D. So what I'm going to have then is worker number 3, and we're going to allocate task D or activity D to that worker. Now, if we look at this, we can show that this is going to start, and again, if you want to refer back here, you can see that we can start this after 8 time periods. So on here, I've shown that it's 8 time periods, and then we will put that just here. So what we've got then is 8 time periods, and we'll take this out now, and it will be just here. So that is activity D, and we'll tick that off. Now, if we look at my scheduling chart down here, and I put D on, we can see now that A must be finished before D can start. Now, if I go up here, I can see that D only depends on A anyway. So I'm breaking no rules by doing that. So that's that one done. So we're now at this stage. So we've got activity B and E completed by worker 2. I'm now at the stage where I'm at this line right here. I've got the choice. So looking now at what I could allocate, I can allocate H or K now to worker number 2. When I introduced the topic, or at least the guidelines, we were told we allocate the one with the earliest late event time. Therefore, I'm going to give worker number 2 H. That isn't absolutely essential, and there are lots of different configurations, but in general, that's one guideline that's recommended. So what we're going to do then is say now H. So H can start just here, and we'll take it to that point just there. So let's go ahead and label H up. So this is going to be H. So we've got H, and then we can tick that off. So let's go ahead and tick this there, and that's that one done. Now if we look, we've got H after E. And again, in our table or in our activity network, that works. H only depends on E. E only depends on B, so we haven't broken now the dependency. So that's where I'm currently sitting. So at this stage now, I've got a choice. So activity H is being completed by worker 2. They're still busy. We've now got activity D completed. So I've got the choice now of G or K. We can see K can be completed a lot later. Therefore, my justification for choosing G for worker 3 is that we've got an earlier late event time. Therefore, we're going to allocate G to worker 3. So let's go ahead and do that, and we'll place that on, and that will go just there. Again, there's lots of scope for maneuver or room for movement on these particular scheduling problems. So let's go ahead, tick that one off. Now, if we look up here, what we've got G, we need G to ensure that it's following D, and quite clearly G is dependent on D only. That's the immediate dependency. So we've not broken anything there, and we simply now have to allocate task K to one of these workers. So task K, I'm going to give it now to worker 2, as worker 2 is going to be finished earlier, and we can simply go ahead and put this on and put K just here. That has a time period of 5, that will go just there, and we can place this on. So in here, I'm going to put that this is K, and we can tick that off, and now my scheduling chart is done. So that's what we have. Often you will see the downtime on the scheduling chart just now blocked out. So from time period 0 to 8, worker 3 is probably sitting around drinking tea and eating biscuits. At this point right here, it's telling me that we've got now worker 2 and worker 3. They've completed early, and they can go home early if they wish. Now, of course, this has implications in the real world for how people are paid, but essentially that's how it goes. So we need to just check that we haven't broken any of the dependencies, which I've done as I've gone through, and that is quite important, but that is one way that you could schedule this particular project. It's certainly not unique, as you can quite clearly see. We could have given worker number 3K, and the fact that I've got such a low value in terms of this, in terms of being close to 2, means that this one was quite easy to schedule. As stated, in the exam, it won't be crazy. They will not give you anything that's too ridiculously tight and needs a lot of messing about with. So the take-home points are as follows. If we want to schedule this now with the minimum number of workers in the critical time, we give activities now A, C, F, I and J, the critical path or the critical activities now to the first worker. We just allocate them and write these out of the equation. We then schedule these, ensuring that we're not breaking the dependencies, and just look at what is logical. As you can see, you can move these all over the place and still ensure that these two don't go past 31 time periods. So there's a brief introduction at looking at scheduling given a critical time. In a later video, we will look at it when we have a set number of workers and we have to complete the project.